Okay, so today I just wanted to go through CS3110 is what most people call it. OCaml Programming, correct, efficient, and beautiful. We probably won't get through the whole thing. It's a somewhat small book that goes through kind of like OCaml foundations, I'd say. If you're experienced in programming but not in OCaml, this is a great book to get started. I've read different parts of it over the last few months, but I've never actually just like read the whole thing. And I don't know if I'm actually gonna read the whole thing, but we're gonna kind of like scroll through it and go through all the examples. Make sure that I understand all the foundations that are at least in this book before we move on to doing some more complicated stuff with OCaml. I wanted to contribute to the Sorta project, and I just felt like I could probably use some better foundations with basics in the in OCaml. So that's why we're here. We're going to scroll through all of this. We already have an OCaml installed, so we don't have to worry about that. But you always could if you want to. Let's see if they recommend anything. Okay. So he's saying create a new switch for CS3110. I probably won't do that. It's basically just to make sure, since this book is on 5.1, that's fair. I'm already on 5.1, so I don't think it's going to matter too much. Oh, but he does have all these things. So what we could do real quick is actually just create a flake that has all of this. So we might as well do that while we're here. See, then I get back to code, and then I want to play music again. This is the problem. So let's see. Let's close our Rust project. Looks like I didn't write that file. That's not helpful. Let's see. I don't know what I have. Let's see. I have a learn OCaml directory with nothing in it. Let's just create a new. Yeah, that's fine. We'll just put it here. So we'll just do CS3110 as its own directory, and then we'll just create a new flake.nix. And then let's see what we might want. So the only thing we're actually going to need here is the dev shell part of this. I don't actually care about this part. So I should be able to just delete the packages section of this and be happy. So we won't need name or version here. Okay, so that's that. Right, I forgot to do. Yeah, this actually should work. Create the directory and wrote. Okay, so let's just open that up in our terminal. Let's see. We'll just do a new one. New as CS3110. And we'll go in here.
Do you spray?
Thanks. All right, cool. Let's just echo a couple things to our git ignore. Definitely, let's see. I always forget the full list. We'll probably do this actually. It'll be easier. Let's just copy libcs. Yep, that looks good. We'll echo a use flake to our mvar_c here and run a direct allow. And that's fine. We just need to do a get init here. There we go. Get init is helpful. And then we'll do another direct allow. Okay, so that will give us at least utop. Oh, this is here, and actually we don't need this line. We're just gonna have build inputs. So that might have fucked something up, but that's all right. So we can actually go through here. And I should be used to having OCaml LSP server defined here, and I so far haven't been like in my dev shell, but it wouldn't be a bad idea to get used to that. Let's just paste this. Oh, it copied that whole line. I didn't mean to do that. It's fine. Let's see. I'm just going to say visual here. And really? No, not what I want. Why isn't it matching on space? Do I just need to do this? And I actually just want to return. Doesn't look like it. It's not happy with that. It's too bad. I was hoping to make this easier. It's okay. We'll just do it this way. Hey, does ZDF see? How do you say your username? Hey, what's up, Priv? Does ZDB? Does ZDB? I guess I can just call you Des. We can try that. Okay. This looks okay. Let's actually do this and something like that. And we'll go here. Okay. So now we have a little dev shell with all these packages in it. Let's see if this actually finishes. I'm going to just cancel this evaluate. I don't know what it's doing. Yeah. What's up next is Noel. Yeah, we are doing what the title suggests. We're gonna do CS3110, but it said it wanted me to create a switch for it, so I'm just creating a little dev shell that has all the dependencies before we get started. So, I mean, you know, instead of using a switch. Whoops. This won't work. We need to have a with OCaml packages there. It's a lot to understand. Man, my computer's hanging right here, but that's okay. It's doing something, and even though I wanted it to give up, it's not going to. So we just have to let it finish. Took you like 5 weekends? No, man, it's a lot. I mean, I've had a lot of help, and it's still not like I completely understand it. I've just gotten used to certain workflows. That's pretty much what it is. Okay, so while that's going, I think we're just going to continue on the book. No, it's a great question. All good? Questions are welcome here, Des. Is OCaml a good language for learning programming if you haven't a background in programming at all? There are people who do it. It's taught in like primary school and stuff. Like, I don't know, I think it's primary school in France. Um, so there is that. I think that I don't think it's so complicated that somebody who doesn't know any programming wouldn't be able to understand it. So I think your main challenge would be finding enough beginner friendly resources um, for you to learn programming in OCaml as a beginner. And there's probably not as many resources for that as there would be for things like Java or JavaScript. Sorry for the swear word, just kidding. Python, etc. I think that might be the only problem you might have if you were to choose OCaml as your first programming language. Poor cow. Poor cow. Thanks for the follow. I appreciate it. Okay, let's see if we can get this working. Okay. Yep. Supposed to be a capital P. Try that again. OCaml LSP server. Okay. It's fine. I'm actually going to take out OCaml LSP server from there anyway, because I actually use it. My global one. Don't tell anybody. Don't tell the next people. I don't remember how I'm supposed to specify OCaml LSP server. It might be that I need to specify it in like my native build inputs or something. I don't know. It's fine. All right, so now it's just downloading some of these dependencies and building them into my shell. But this is usually a good sign that everything's been found. Let's go. Okay, cool. So now I have utop and I have all the packages that I'm supposed to have. So that's cool. Great to have. Okay, so let's move on. All right, so I don't think this isn't anything special, but we can put in 3110 as an int in utop. Okay, very cool. Double check OCaml. Sure, don't have any problems with our installation. We're going to move past all of this and get into the actual book. All right, now I'm going to pause music. Better programming through OCaml. Did you already know how to program in a mainstream language like Python or Java? Good. This book is for you. It's time to learn how to program better. It's time to learn a functional language, OCaml. Functional programming provides a different perspective on programming than what you have experienced so far. Adapting to that perspective requires letting go of old ideas, assignment statements, loops, classes, and objects, among others. That won't be easy. Nan-en, a Japanese master during the Meiji era, received a university professor who came to inquire about Zen. Nan-en served tea. Might be in, I don't know. Usually E. Usually I is pronounced E in Japanese. He poured his visitor's cup full and then kept on pouring. The professor watched the overflow until he no longer could restrain himself. It is over full. No more will go in. Like this cup, Nanin said. You are full of your opinions and speculations. How can I show you Zen unless you first empty your cup? All right, nice. Functional programming is Zen. How about it? There's literally, I'm just going to refund your points to me. I'm not doing an IRL voice ban in this stream. I'm sorry. It's not going to happen. It's not going to happen. The whole point of this stream is reading a book. I'm not going to do a voice ban right now. If I was coding, I would do it. There you go. You gave your points back. Okay. I know. I believe that learning OCaml will make you a better programmer, and here's why. You will experience the freedom of immutability, in which the values of so-called variables cannot change. Goodbye, debugging. You will improve at abstraction, which is the practice of avoiding repetition by factoring out commonality. Goodbye, bloated code. You will be exposed to a type system that you will at first hate, because it rejects programs you think are correct. But you will come to love it, because you will humbly realize it was right, and your programs were wrong. Goodbye, failing tests. You will be exposed to some of the theory and implementation of programming languages, helping you to understand the foundations of what you are saying to the computer when you write code. Goodbye, mysterious and magic incantations. All of those ideas can be learned in other contexts and languages, but OCaml provides an incredible opportunity to bundle them all together. OCaml will change the way you think about programming. Probably true for you guys. But, you know, not as much for me. Not as much, because I'm just that good. No, the real truth is I learned Haskell before I learned OCaml. And Haskell definitely changed the way I thought about programming. And OCaml is like a nice way of doing that. Space Time, what's up? Thanks for the raid. I appreciate it. Hope you had a good stream. We were doing some OCaml learning today. Of course. Yeah, no worries at all. Super appreciate it. Welcome, raiders. I'm Meta or MetaMe. Well, we'll turn on some music for a second. Yeah, I do OCaml and Rust and Nix stuff mostly these days. I've been doing quite a bit of OCaml in the last couple months, and I felt like I could use some better foundations and just some basics of the language. Maybe not basics, maybe more advanced stuff. And so I thought I might as well go through this book, CS3110, which I've done a few times, read parts of, and thought we could read most of it on stream, work through some things, and I'll just pin that up there. That way you guys have a link in case you want to look at this book later. So this is an open source book that is used to teach a course, given the title. And the full title of the book is OCaml Programming, Correct and Efficient and Beautiful. Since I know you guys do a lot of Rust over on the space-time thing, I will point out I have a couple things that might interest you in the Rust realm. We did some data structures and algorithms in Rust. And currently I've been working on just a silly little CLI tool, but that's kind of like my current Rust project. We'll probably get back to data structures in the next month or so and probably rewrite all the ones that I already did now that I know Rust better than I did, and then get into maybe some new data structures as well. So thanks so much for the raid again, Space Time. I know you're already gone, and welcome, raiders. Let me know if you have any questions. Okay, so I'm not going to read this book word for word because that's not really my point of going through it. If you guys want to read some of the extra text, you can always go read this book yourself. I'm mostly making sure that I understand some of the basic things that OCaml has, and like what they're called, the syntax, etc., etc. Des says, what language can you recommend to learn first? My goal is to change my current work, but I'm stuck now because of a lot of languages and I don't know which to choose. Yeah, Des. So a great answer, if your goal is to get a job the best answer is to look at the jobs that you would want to get and what language do those jobs use. It depends on where you live. It depends on what industry interests you. It depends on like what you want to do. So that's what I would suggest, is actually just going and looking at a bunch of job descriptions. Are you mostly seeing a bunch of Node jobs out there? Do you want to do front end or back end, full stack, all those things? Look at the jobs that you want to get, figure out what those jobs require, go learn those things. It's better than just like me saying, "Oh, this is the best language to learn first," because your goal is to get a job. So figure out how to do that. That was my goal over 10 years ago. And I chose JavaScript because that's where I saw most of the jobs. And that was what was hot at the time. And so I learned full stack JavaScript, got my first job, and then figured it out from there. Moved on. Now, so my first job was like JavaScript, Java, then TypeScript came out. So we started using TypeScript in Java. Found out I really liked functional programming, so I moved into working with Clojure full time, and found out that I liked the back end a lot more than I like anything else. So I got a job doing Clojure on the back end, and I've been doing that for a few years. Lately, I've been, I really like types though, so now I'm, building my skills in Rust, which I really like. OCaml, all that good stuff. Yeah, a lot of work as a web developer. Yeah. So I mean, I think that's what you got to do. Go see where the work is. Learn those skills. You don't have to learn everything, but that's what I would start with. Spend a week with different languages. See which one you like better after spending a week with different languages as a beginner. What clicks better with your brain? I think that's a good way of going about it too. Okay, so let's read this little section. I think it's good. I guess we're gonna go back to pause music. It's gonna make the YouTube video really dumb if I keep saying that, but oh well. It's too bad. OCaml supports a number of advanced features, some of which you will have encountered before, and some of which are likely to be new. Algebraic data types. You can build sophisticated data structures in OCaml easily without fussing with pointers and memory management. Pattern matching, a feature we'll soon learn about that enables examining the shape of a data structure, makes them even more convenient. Type inference. You do not have to write type information down everywhere. The compiler automatically figures out most types. Parametric polymorphism. Functions and data structures can be parameterized over types. This is crucial for being able to reuse code. Generics, basically, right? In case people were wondering. What are these little links? Okay, interesting. Annotations in Chinese. Helpful. Mandarin, something. Garbage collection. Automatic memory management relieves you from the burden of memory allocation and deallocation, a common source of bugs in languages such as C. Modules. OCaml makes it easy to structure large systems through the use of modules. Modules are used to encapsulate implementations behind interfaces. OCaml goes well beyond the functionality of most languages with modules by providing functions called functors that manipulate modules. Nice. Okay, OCaml in industry. It's pretty short. For my work I do Clojure on the back end, which is a Lisp that works on the Java virtual machine, so it interops with Java. Look to your future. Okay. So OCaml is a general purpose programming language. We already know about that. There's a lot of videos and stuff that you could look at this. Here's a brief history of the course that this guy teaches. The Halo, I've really only seen OCaml used in college courses. I haven't been exposed to much of it in production. Are there any use cases that it's well known for or notable things that are built in it? Probably the most notable would be Jane Street, which is a... So if you ask most people who work with OCaml, this is what they'll say. Jane Street, which is a equities company. They use OCaml. They're probably the biggest user of OCaml in industry. So that would be one. There's definitely other companies that are using it, but that's definitely like the biggest. OCaml.org actually has a really nice list. Let's see if we can find it real quick. Let's see. I know Sabine was working on this list to show industrial users. Perfect. Okay. Oh yeah, Bloomberg is another one. They have a team of like 50 OCamlers or something. There's a guy that is in the caravan in our Discord that works for Bloomberg. And then there are OCaml projects at all of these companies. And I know the Dark Reader kind of messes this up, but this is just Jane Street. So yeah, quite a few. It's not huge by any means, but there's a few. And that's here. What's up, Tired Beaver? Yeah, it is cool. All right, 1 second. Quick message check. We'll get back into it. Okay, so summary. This book is about becoming a better programmer. Studying functional programming will help with that. Totally agree. The biggest obstacle in our way is the frustration of speaking a new language, particularly letting go of mutable state. Very hard for a lot of people. Clojure, which I use full time, have for 5 years, it's immutable, so I'm used to dealing with immutability. But the benefits will be great. A discovery that programming transcends programming in any particular language or family of languages. Okay, got it. An exposure to advanced language features and appreciation of beauty. And an appreciation of beauty. That's what OCaml teaches you. Terms and concepts. Okay, dynamic. So they're just giving us a list of terms and concepts without telling us what they are. I'm a little confused by that part. How does this help? I know what all these things are, but like why do we have terms and concepts without an actual definition of them? Okay, that's fine. Further reading. Objective Camel, that is the original thing. So there was a quick history of OCaml, right? There was ML, right? And that was like the original thing, Henley Milner type inference. And then SML came out of that. Like, and there's some different parts of that, but like SML and J, right? And then Camel came later, categorical abstract machine language, pretty sure. And that came in like the 80s, if I remember right. And then ML was in the 70s. Camel was in the 80s. OCaml was in the 90s. And that's because OCaml actually does have some object-oriented features in it, even though it's a functional programming language. So has classes, has a couple other things, has the ability to do mutable objects, stuff like that. Okay. Basics of OCaml. Let's see. Learning languages in general. Yeah, I like this part. I read this before, but he says there's 5 essential components to learning a language: syntax, semantics, idioms, libraries, and tools. I think this is helpful, but it's easy to forget. And he like as most college professors do, he then like goes on and like uses the same model like over and over again, and like, let's start with learning the syntax of this. Now we'll talk about the semantics of this. And it's just kind of like, I don't know. It's probably just a little too academic for me in some ways, but that's okay. It still could be helpful. So we can just skim this real quick. By syntax, we mean the rules that define what constitutes a textually well-formed program in the language, including the keywords, restrictions on white space, and formatting, punctuation, operators, etc. Basically, syntax is what you actually type. That's the way I think about it. By semantics, we mean the rules that define the behavior of programs. In other words, semantics is about the meaning of a program, what computation a particular piece of syntax represents. Note that although semantics is plural in form, we use it as singular. Okay. There are two pieces to semantics, the dynamic semantics of a language and the static semantics of a language. The dynamic semantics define the runtime behavior of a program as it is executed or evaluated. The static semantics define the compile time checking that is done to ensure that a program is legal beyond any syntactic requirements. Okay, cool. So like static semantics in OCaml, type checking, static semantics in Rust, type checking, borrow checking, lifetimes, the whole thing, right? And then dynamic semantics, I think, is like pretty self-explanatory. What actually happens when your code gets executed or evaluated. Okay. Idioms, we mean the common approaches to using language features to express computations. Right. We all know, most people in the industry, like when people say this is idiomatic, Python, Clojure, OCaml, right? Idioms. How do people usually do these things? Libraries and tools. Yep. Cool. I think one of the things that I think he's probably also pointing out here, though, is like, how do people usually do it? Like boot camps and stuff, right? In boot camps, you learn libraries and you learn tools. And then you learn idioms. Like you kind of go from the bottom of this list up. And I think maybe part of his point is like, we could learn from the top of this list down. I think that might be part of the point as well, which I would mostly agree with. Like don't learn a framework, learn a language, sort of thing. OCaml top level, that's, most people would just call that a REPL. So OCaml's top level REPL, same thing. In OCaml, that's utop. We already installed utop using our flake, and this is what it looks like. If you're not familiar with a REPL, it just basically gives you a way to interactively execute code. So above there, we did 3110, double semicolon. Yeah, it's an OCaml thing, just to say execute this. We could also say hello chat, double semicolon. Now we have a string that's hello chat, right? And of course, we can actually do other things. Let's see, caret chat, and we can concat our string, right? Stuff like that. All right, types and values. I don't think we need to go through this too hardcore. The point is that you put in a value, utop tells you what the type of that value is, like the type and then the value that X evaluates to. This looks good. You can bind values to names with a let definition. Yep, pretty normal. So people are pretty used to this. It's the next part that people are not as used to, right? So we have X, and now we have that, kind of like you would in most other languages. 1 second. All right. So we don't need to spend too much time on that. And to define a function in OCaml, you also use let, at least here. So this is his example, right? x equals x plus 1. And this is where OCaml gets funny, and the book will go into this, but that's because of currying, which we'll probably see in a second. I think this is helpful for people new to OCaml, though. We'll read this real quick. So int to int is the type of the value. This is the type of functions that takes an int as input and produce an int as output. Think of the arrow as a kind of visual metaphor for the transformation of one value into another value, which is what functions do. How about that? Fun itself is not a value, it just indicates an unprintable function value. Yeah, so he's just talking about this fun right here. You can call functions with syntax like this, right? You just call it, you don't use parens, you don't use anything. You can use parens if you want to, but you don't have to. Unless, of course, you want to apply it twice. And that's very similar to like what you'd write in other languages, C-like languages. All that means is this, basically, right? Increment 5, right? But in OCaml, you don't have to do that. If you just wanted to increment 5, you can do this. If you want to increment twice, you can do that. And that does kind of the same thing as would happen in, I mean, the way that parens work, a little bit similar to how they work in other languages. A little bit. It's a way of controlling what gets executed first. In OCaml, would be cool to do increment caret to 5. That would be pretty cool. I don't disagree. That'd be kind of fun. In OCaml, the usual vocabulary is that we apply the function rather than call it. Note how OCaml is flexible about whether you write the parentheses or not, and whether you write white space or not. One of the challenges of first learning OCaml can be figuring out when parentheses are actually required. So if you find yourself having problems with syntax errors, one strategy is to try adding some parens. The preferred style, though, is usually to omit parentheses when they are not needed. So increment 21 is better than increment 21. Yep. Loading code in the top level. Okay. Let's see. So this is just talking about how we could use the top level. Right. So we could do this real quick for funsies, because we'll probably have to do this anyway. So let's just create a new file, and we'll just do it this way for now. And we'll put that into mycode.ml. And then here we should be able to just say use mycode.ml. And it can't find it. Perfect. This is exactly what I wanted. Okay. Hey, what's up, Prophet? So why doesn't that work? Do I need, like, what if I do this? Cannot find? Where's it trying to look? Okay, let's see. Does this? Oh, I did something wrong. Ha! I put the file in the wrong. I wasn't in the right directory. It might help if I was in the right directory. So utop was not wrong, surprisingly. I know we're all surprised, but utop was not wrong. It was me. It was a skill issue. Okay. So let's go back to utop. And we shouldn't need this. There it is. Yay. And so like this is a module technically, and it tells us, hey, this has a function called inc. And there we go. Now we can use inc. That we defined in mycode.ml. If you have an actual project, like you can use Dune utop, and it will kind of like make some of this easier as well. But you'll still have to like open modules and stuff, but it'll get to that. Yeah, Prophet, we're just going through CS3110 a little bit. Just thought I could use that because, like, it's great to learn things writing projects, but I haven't read this whole book before. Figured I would speedrun it. Storing code in files. We just did that. We just effing did it. Okay. Open a terminal, create a new directory, and open. Why are they doing this to me? What the heck? Almost swore on stream. Okay. Make dir hello world, cd hello world, sure. Do not use the root of your Unix home directory as the place you store the file. I love that. Okay, use VS Code to create. Oh no, I said it. Named hello.ml. Enter the following code. Sure. Okay, we can do this real quick. You know what's surprising is you actually to do this. I mean, people probably don't know this, but to do this, you don't actually need an editor. You can just use the command line. All right. Hello.ml. And this works very similar to C, right? We give it a little of this. And we'll just put a little bit of there with hello.ml. Oh yeah, I don't have OCaml C installed because I don't. It's really funny. Let me think. How can I do this easily without screwing everything up? Okay. Is OCaml C just in OCaml packages for Nix? I actually don't know. Nix packages. I always forget how to search Nix packages. There it is, search.nix packages. Yeah, I defined utop in my Nix flake, but I didn't put OCaml C. Okay. No. What happened to search.nix packages? Why did I get this? Oh no. What happened to search? Okay. It went somewhere else? Weird. That used to work. Okay. Let's just see. I'm guessing if I just bring in this nixl-p OCaml programs provided OCaml C. Okay, this is what we need. So we will just put OCaml up here. Nice try. And this should work. I'm so used to using this flake in a Dune project that I don't actually install OCaml outside of it. But this should have given us. There we go. Now we have OCaml C. We can do things. Okay, awesome. OCaml C, it's there. So we compiled the code and we should be able to just execute our hello. Yay, OCaml. Okay. It should print hello world and terminate. So good at programming. Oh my God. Now let's clean up all those generated files. What if I don't want to? What if I like the generated files? Okay. I guess we can do it this way. I could have just copied what he put. That's okay. All right. Fun. Unlike C or Java, OCaml programs do not need to have a special function named main. Great call out. The usual idiom is just to have the very last definition in a file serve as the main function that kicks off whatever computation is to be done, right? Yep, that makes sense. Okay. And then we're going to talk about Dune. Sure. So instead of using make, they say use Dune. That's fair. Creating a Dune project manually. Let's see. I feel like I already, pretty much know how to do this, but that's fine. Sure. Yeah, we'll do this. So pb paste into Dune. And there it is. How about it? And then what do we have to do? I can't remember. Do we need, it needs a Dune project, doesn't it? That's right. Because without a Dune project, they'll just think this might be just a source directory instead of like the actual project directory. Oh, that's hilarious. It literally explains it right here. Classic me. This tells Dune that this project uses Dune version 3.4, which was current at the time of this version of the textbook was released. The project file is needed in the root directory of every source tree that you want to compile with Dune. In general, you'll have a Dune file in every subdirectory of the source tree, but only one Dune project file at the root. Yeah. This is true. Okay. So what do we have? We have that. That can be our Dune project. And what I don't remember, I don't even have Dune. So let's add Dune to our thing. Now, we're going to do it this way. Typically, what you do for a real project is, of course, you'd actually tell Nix to build it. But for now, I'm just going to continue for the sake of this. And we should be able to just do something like that. Get Dune from Nix, and then we'll just use Dune to build, which is also fine. Like if your whole point is to use Nix just as your dev shell and not your build tool. Okay, let's find that in Nix packages, shall we? Shall we find it? Unstable is fine, actually. I want to see Dune, though. Dune 3. All right. Yeah. Yeah. No. Okay. 1 second. Okay, here we go. What's up next? I guess it's Dune _3. That will probably work. Isn't Dune backwards compatible? Yeah, I think so. I don't know. Never really thought about it, to be honest. But it looks like in Nix packages, it's Dune _3. That's all my point is here. Query nickshell env. Unable to download. SSL connect error. Oh, that's what you mean. Yeah. It is kind of interesting, but whatever. Okay, so we should now have Dune. Yay, we do. And we can go back to the book. Okay, so we did this, and then we have this beautiful, beautiful thing. One of my favorite parts of Dune, which is no matter what OS you're on, if you're building a single OCaml file, you say build hello.exe, or you use .exe after your project name. So that's pretty fun. Just came to say hi. Yeah, cool. See it. What's up, Dylan? How's it going? I didn't even see you say hi earlier. I skipped right over you. How you doing? We're just going through CS3110 a little bit. I know. Just typically me ignoring you. That happens so often. Okay, so we can actually just call it directly from build. No, not what I'm looking for. I guess Zshell really wants me to do that for some reason. That's fine. There we go. There it is. Or we can say Dune exec. Is the first part actually necessary? Yeah, it is. How about it? We can do that. Yay. And we can just do Dune clean, but we have build ignored anyway, so it doesn't really matter. Okay. When Dune compiles your program, it caches a copy of your source files in _build default. If you ever accidentally make a mistake that results in loss of a source file, you might be able to recover it from inside build. Yep. Don't edit files in the build directory. How about it? Okay, creating a Dune project automatically. Yep, we can init projects. I'm not going to go through that because I already know all about that. And we can run Dune build watch as well. Always nice. Okay, so let's look at expressions. Let me do a quick message check here. I think we're good. 2.3, expressions. The primary piece of OCaml syntax is the expression. Just like programs in imperative languages are primarily built out of commands, programs in functional languages are primarily built out of expressions. Examples of expressions include 2.2. How about that? 2 plus 2 and increment 21. The OCaml manual has a complete definition of all the expressions in the language. Though that page starts with a rather cryptic overview, if you scroll down, you'll come to some English explanations. Don't worry about studying that page now, just know it's available for reference. Very exciting. The primary task of computation in a functional language is to evaluate an expression to a value. A value is an expression for which there is no computation remaining to be performed. So all values are expressions, but not all expressions are values. Examples of values include to, true, and yay. Yatta! The OCaml manual also has a definition of all the values, though again, that page is mostly useful for reference rather than study. Sometimes an expression might fail to evaluate to a value. There are 2 reasons that might happen. Evaluation of the expression raises an exception. Evaluation of the expression never terminates. So what do you mean it has a definition of all the values? Like obviously not every possible value. Describes the kinds of values. It's a little different. That's a little different. All values are expressions, but not all expressions are values. Okay. All values are expressions isn't true, is it? Like a continuation or closure value isn't an expression, is it? Yeah. I feel you. Or a reference, yeah. Huh. I wonder why they say that then. Here we go. Google's, it's definitely going to be right. Perfect. Yeah. I don't know. Interesting. Interesting. I'm trying to think like I think that is true in I feel like that would be true in like Lisp. I'm trying to think of an example specifically in Clojure where there's a value that's not an expression, and I'm pretty sure that's not going to happen. Yeah. Pretty much not. But yeah, I mean, well, that's a good point. If I'm doing Java interop code, then that's kind of out of the window. But yeah, in in like just normie Clojure code, I guess they say that because you can interpret them like that in a pure language. Yeah, but not if you have unrestricted effects. Yeah, yeah. I mean, I would say it's true in all the toy examples we'll play with, but probably not true once you start doing anything more complicated. Maybe not anything, but like you said, if you have effects and all that. Yeah, interesting. Okay. Um Sometimes an expression might fail to evaluate to a value. There are two reasons that might happen. Evaluation of the expression raises an exception. Evaluation of the expression never terminates. There. Primitive types and values. The primitive types are the built-in and most basic types: integers, floating point numbers, characters, string, and booleans. We're just going to skim past this real quick. Pretty normal. It's not percent. I'm very sorry to say it's not percent. You have to type out the whole word mod. And of course, it's not actually. Yeah, I knew it. I knew you were going to say that. I was trying to get to it before you typed it, but you're too fast. Too fast for me. Too fast for my old brain. And it's not really mod. It's REM, okay? But we all need more REM sleep. Bad joke. Really bad joke. Okay. Dividing by 0 is an exception. I'm a fan. Actually, I'm a fan of division returning an option. And, I think, 65 divided by 0 should just return none. Right, Prophet? Right? That's a joke. Okay. OCaml integers range from 262, negative 262 to 262. Wait, I'm so confused. Oh, -1. God, this typeface. This just looks like a dash. That does not look like that looks like a, what is that called? Like a double dash. That does not look like a minus sign in this typeface. Sorry to say. Okay. They are implemented em dash. Yeah. I was like, how do I read this? All right. They're implemented with 64-bit machine words, which is the size of a register on 64-bit processor. So basically, they're i64s, kind of. They're i63s. But you can use the int64 module if you need true 64-bit integers. Yeah. Um, and for applications that need arbitrary precision integers, there is a separate zarif library. But for most purposes, the built-in int type suffices and offers the best performance. Type float, floating point numbers. OCaml floats are IEEE 754 double precision floating numbers. So this is the part that like trips people up a little bit in OCaml. This is fine. Like that's not that trippy, right? The inferred type with 3 dot is a float of 3 dot, and with no dot, it's an int, right? But it's just that the operators all require dots. That part might confuse some people. But yeah, fun times. Oh, and then of course, if you're, I mean, not trying to explain it for everybody, but if you're coming from a dynamic language where you'd get like a double or a float from this sort of operation, that's not going to happen here, right? We get an int. Yeah. How about it? So yeah, floating point operators have a little dot at the end, and that happens all through here. Great. Type booleans are true and false. There's and, logical or, similar to, whoops, C-type languages. No, what did I do? Stop this. No, just get the hell out of here. All right, we're good. We're good. So this is why I don't read books on the internet. I get too confused. I just put PDFs on my reader. Okay. So logical and logical or. Pretty normal. Exciting. Car characters are single quotes. Pretty typical. You can convert characters to and from integers with car event and int of car. Okay. Type string. Strings are sequences of characters. They are written with double quotes such as ABC. Yep. Normal thing. Yeah, but cars are bytes. Oh, they are represented as bytes. I skipped over that sentence. Okay. Nice. Okay, what does this say? Object-oriented languages often provide an overridable method for converting objects to strings, such as toString in Java or str in Python, but most OCaml values are not objects, so another means is required to convert to strings. For 3 of the primitive types, there are built-in functions: string of int, string of float, string of bool. Yeah, very typical OCaml, I have found out. It's all here. Strangely, there is no string of car, but the library function string.make can be used to accomplish the same goal. Can it though? Can it really? Pretty close. Okay. Likewise, for the same 3 primitive types, there are built-in functions to convert from a string if possible: int of string, float of string, and bool of string. Why not add it if it's strange? Yeah. I wonder, does anybody know? Why don't we have string of car? Pascal, thanks for the follow. I appreciate it. Yeah. Strangely, this doesn't exist. It's unfixable though. I'm guessing what is string.make? Int car string. Okay. I'm guessing that's like what's the integer in string.make? But it would be redundant. Yeah. Nice. string dot make OCaml module string. The fact that I don't have docs in the REPL hurts, by the way. No docs in REPL hurts me. I just want a basic doc. I just want you to tell me what the arguments actually are. Obviously I can get the type, but I just want the doc string, okay? It's not that hard. Imagine not having docs in a REPL, right? Does Elixir have docs in their REPL? Try. Of course, yeah. I was gonna say. I mean, of course it does. We're not barbarians. GHCI does. I remembered that. I was very surprised that UTOP doesn't have docs. There's like an abandoned project that tries to make a better top level. I didn't feel like messing with that. Is a string of length n with each index holding the character C. Nice. Okay. So string.make for z is just okay, we should do 3, right? Zzz. Yeah, UTOP is already the better top level. Yeah. I mean, UTOP actually, for the most part, is really great. Oh, you mean even compared to GHCI? Yeah. Yeah, a little early today. And it showed. It showed. I had like 3 people for 15 minutes and I was crying. It was really bad. I was crying in the corner. Lots of tears. Makeup went everywhere. Oh, just compared to just OCaml. Okay, I was gonna say. I didn't feel like that was probably true. Yeah, I'm not surprised. I always felt like when I used GHCI, I never felt like I was missing anything. I mean, not like I've used it a lot, like I haven't written a lot of Haskell, but yeah. I think so far the main thing that I wish UTOP had is doc strings. That's the main thing. Okay, cool, Whimsically. Enjoy. Is it time to break your fast? Is this me being ignorant, not knowing something that's happening right now? When's Ramadan? Okay, not this. Maybe I don't understand Ramadan very well. That's also possible. I don't understand Ramadan very well. Shocking that I wouldn't understand it well. All right. Yeah, it is Ramadan time. Okay. Hey, at least I had that in my mind. Even though I may not understand it, at least I had it in my mind. I knew it had something to do with fasting. Oh, sunrise to sunset. Okay. Okay, there you go. Thanks. Good to know. Okay. Okay, so that's what string.make is. Interesting. Yeah, I think we should still have a string of car. Sorry. I think string of car is the right choice here. But that's okay. The same 3 primitive types, there are built-in functions to convert from a string if possible. Int of string, float of string, bool of string, sure. And what happens with bool of string? What's the type? Bool of string is string to bool. So do we just get a panic? We just get a panic AHC. How about that? Yep. An exception. Sorry. Okay. That's why bool of string opt exists. Is probably even there, right? And I didn't even notice. It was there and I didn't even notice. Hilarious. Hilarious. Nice. Markdown doc comment rendering. Oh, wow. All right. Yeah, that's pretty. That is pretty. Yeah, closures isn't that good. It's pretty good though, but it's not that good. There's a nice Emacs plugin though for getting like basically closuredocs.org in Emacs, but I don't usually use it. Usually the doc string's enough. I don't need to think about it too much. Okay, where were we? I don't know if this is really speed running, but that's okay. I'm having fun, and it's reminding me things. Okay, int of string, not an int. Sure, good times. There is no carved string, but the individual characters of a string can be accessed by a zero-based index. The indexing operator is written with a dot and square brackets. Yep. Okay, abc.0, a, b, and exception. Exciting. We've covered most of the built-in operators above, but there are a few more that you can see in the OCaml manual. There are 2 equality operators in OCaml. This part's very important. Equals and double equals with corresponding inequality operators, something and not equals. Operators equal and something. Examine structural, like how can I read this? How do OCamlers read this operator? How am I supposed to say that out loud? Yeah, but this is not equals. This I can say equal and double equal. This is left arrow, right arrow, and not equal. It's fine. Come on. Okay, operators equal and special not equal. Examine structural equality, which is what you want, by the way. Whereas equals and not equals, double equals and not equals, examine physical equality, which is not what you want. Until we've studied the imperative features of OCaml, the difference between them will be tricky to explain. See the documentation of stdlib. Stdlib dot equal if you're curious now. But really, you don't really want that. Fair. Yeah. Just don't use double equals, okay? It's just like, it actually is the best thing I've heard, is it's just like JS. Don't want to use double equals. But of course, you also don't want to use JS. So that's where that kind of breaks down a little bit. Assertions. The expression assert E evaluates E if the result is true. Nothing more happens, and the entire expression evaluates to a special value called unit. Let's go. The unit value is written, open, close parens, and its type is unit. But if the result is false, an exception is raised. One way to test a function f is to write a series of assertions like this. Yeah. Right. What she said. One way to test a function f is to write a series of assertions like this. Yep. Assert. Those assert that f input 1 should be output 1 and so forth. The let equals part of those is used to handle the unit value returned by each assertion. Yeah. So yeah, I mean, it is one of the confusing things for some people is that if I say let a equals false equals true, which should evaluate to false, by the way, that confuses some people. But it's just based on where that equals sign is. The compiler knows what to do with it. But yeah, I don't know. I'm somewhat used to it only because of Clojure, but of course it makes more sense because we don't actually use equals for assignment. So we just say, you know, equals false true. Yay, Lisp. We're so great. But yeah. If expressions. The expression if E1 then E2 else E3 evaluates to, okay, E2 if E1 evaluates to true and to E3 otherwise. Bet you guys never would have figured that out. We call E1 the guard of the if expression. If 3 plus 5 is greater than 2, then yay, else boo, string yay. So, of course, these are expressions, not statements. They can be put anywhere. So you can do fun stuff like this. Very exciting. If expressions can be nested in a pleasant way, I think this is fine. I mean, you know, it's not bad. It's not bad. You should regard the final else as mandatory, regardless of whether you're writing a single if expression or a highly nested if expression. If you omit it, you'll likely get an error message that for now is inscrutable. This expression is type int, but an expression was expected of type unit because it is in the result of a conditional with no else branch. Yeah. The syntax of an if expression. If E1, then E2, else E3. The letter E, okay, we're not going to read all of this. So this is like what he likes to do in the book, and I think it's helpful, but not to me. No, I mean it's okay, but I usually don't have the patience to read through this. I just don't have the patience for it. Should be written in inference rules. That would be nice. What's funny is I don't have the patience for this, but if we go to like what is it? Rust reference. I'm fine with this. I can read this just fine. Give me this over whatever the other one is. I'm happy. I can read this. This makes sense to me. Giving me a bunch of special things doesn't make me very happy. I don't know. Just the way I like to process information, I guess. Okay. Sure. Just explaining how the types work with an if. All that sort of thing. Yeah, this is helpful. We're going to be writing has type a lot, so let's introduce a more compact notation for it. We would write E has type T. Let's instead rewrite E has type T, right? Yep. I like this. This is one of the parts of this book I kind of like, is it tells you how you should pronounce things. I think that's helpful for people. I like that. Let expressions. Let's see. In our use of the word let thus far, we've been making definitions in the top level and in .ml files. For example, let x equals 42. You guys ready for let in? Are you ready? So then you can use x in future definitions at the top level. This is what most people are used to, right? You define a variable, then you use it. Very imperative way of working. You still don't know how to pronounce that in Haskell, yeah. Star. You just pronounce it star. Just kidding. Expanding star. Supernova. You pronounce it supernova. Okay. We'll call this use of let a let definition. Yeah, supernova is pretty good. I'm pretty impressed with myself right now. There's another use of let, which is as an expression. Let x equals 42 in x plus 1. Okay, so yeah, this is very common. I'm used to this, but you know, something, if you're not used to OCaml, this is going to be kind of confusing to a lot of people. I think that's confusing to a lot of people. But yeah. Here we're binding a value to the name x and using that binding inside another expression x plus 1. We'll call this use of let a let expression. Since it's an expression, it evaluates to a value. That's different than definitions, which themselves do not evaluate to any value. You can see that if you try putting a let definition in place of where an expression is expected, let x equals 42 plus 1, you get a syntax error. Okay. Yeah, I never really thought of it this way because I would never think of writing code like this, but it makes sense. So if right, this just ends up returning the signature of whatever I just typed in, like my declaration. Third eye is pretty good. I like it. Syntactically, a let definition is not permitted on the left-hand side. I don't remember what that does. What does that operator do? I forget. So many operators in Haskell. I like them, but there's a lot. I don't remember what they are. Application inside an applicative. Okay. Let x equals 42 and x plus 1. Cool. Another way to understand let definitions at the top level is that they are like let expression where we just haven't provided the body expression yet. Implicitly, that body expression is whatever else we type in the future. Yeah. Fair. What is my computer doing? Elvis operator or shorthand ternary? Yeah. It looks like robotic clotomy. That's funny. Implicitly, that body expression is whatever else we type in the future. Yeah. Okay, that makes sense. The latter series of let bindings is idiomatically how several variables can be found inside a given block of code. Syntax let x equals e1 and e2. Blah, blah, blah. Blah, 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 blah. Blah, 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 blah. Okay. Hey, Dapper King. Oh no. I probably shouldn't open things from Ryan in my streamed window. And this is why. This is why I'm not supposed to open things from Ryan directly into my streamed window. What does this even do? What does that do in TS? Oh my god. That is very funny. Okay. Nice. Lesson learned yet once again. Special Ryan window, yeah. Oh, right. That makes sense. That makes sense. Okay. Haven't written TS in a while. Okay, so we learned about let-ins, all that stuff. Exciting. Now we're going to learn about scope. Let bindings are in effect only in the block of code in which they occur. This is exactly what you're used to from nearly any modern programming language. Are you sure about that? For example, let x equals 42 in x plus, let y equals 3110 and int of string y. The scope of variables where its name is meaningful. Yep. It's possible to have overlapping bindings of the same name. Shadowing, let's go. Is this actually true that shadowing is discouraged in OCaml? I haven't noticed that. Most people I talk to like shadowing. Oh, I see. It's because, I mean, this particular example, yes, this is terrible. Don't write this code, right? Don't write code that looks like this. But you can do shadowing in a way that's not terrible. That's all my point is. That's all my point is. The compiler uses so much shadowing, yeah. Okay, I don't care about this. You guys can learn about scope if you want to. I'm not confused about it. So we're going to keep going. Shadows functions all the time, yeah. Okay. Yep. Okay. So then he explains shadowing in detail. I kind of think if you were new to programming, this book isn't all that terrible. If you actually, I'd be interested. If you didn't know any programming, how hard this book is, because it's rather verbose. There's a lot of detail in places that I feel like most people don't need. Most people who know programming don't need this amount of detail, but maybe I'm wrong. I mean, it is one of the things that you have to learn when you go to a new programming language, right? Is like, how does that programming language treat scope? So maybe that's why this section seems so long to me. And maybe I just don't care enough. I don't know. To summarize, each let definition binds an entirely new variable. Probably not, Dapper. I mean, a good first FP. I don't know. I mean, I so far like what I've seen of Gleam. It looks fine. Seems to be pretty practical. Which is an overloaded word in functional programming sometimes. I think like where are you coming from? I think that's also important. Like what are you used to can help you make bridge concepts better. So a lot of people that come from Ruby, of course, they like to learn Elixir because the syntax is very Ruby inspired. And then they don't have to think that much about syntax and they can just learn the concepts. Yeah. Yeah. I mean, if any resources were there for interest too, right? SRE DevOps, you work with a lot of Go and Python. I mean, I think what is a good FP is like one that like most people will hate this experience this answer, but I think it's the one that when you are using it, you're like, okay, I think I can understand this some. That said, whether I think it should be your first or not, learning something like Haskell that forces you to think about how you model your side effects and enforces like some standard of purity can really, really change the way that you think about programming. That aside, if you're just needing to learn like a more functional way of thinking, using immutable values, how do you model things when figuring out how to use map and bind and results and all those good things. Not that all of that is exactly functional programming, but it's orthogonal. Then I personally don't think it matters that much what you start with. I think Gleam has some nice interfaces and APIs, and it can be exciting to be in a somewhat new new community. That said, I haven't used it that much, but people I respect have used it and have liked it. So besides Dylan, I don't respect Dylan, but he likes it as well, for what that's worth. Just kidding, Dylan. All right. He's probably in a meeting anyway. Oktorinsky, thanks for the follow. I appreciate it. I like you, Dylan. All right. Yeah, I think Haskell has concepts that very few. It has concepts and resources. I'll say the combination of those two that I think people not used to functional programming can actually use to learn pure functional programming. So I think that's one of the reasons I would recommend Haskell for that sort of thing. But you can still learn a lot. OCaml, Gleam, even dynamic functional programming languages, still learn a lot. Type annotations. OCaml automatically infers the type of every expression with no need for the programmer to write it manually. Nevertheless, it can sometimes be useful to manually specify the desired type of an expression. A type annotation does that. Yep. Exciting. Yep. Okay. We're getting there. Nix has been cool to learn as your first FP. Oh, that's interesting. Yeah. I mean, it at least gives you those concepts of like defining everything with a function, being pure. It has a lot of those kinds of things in it, right? It's clear that the type annotation has failed. Yeah. Okay. We know about the syntax of type annotations. Functions. Functions describe the world. Okay. Let's see. 231. We got about 30 minutes left. We might be able to get through chapter 2. It's funny that I was hoping to get through the majority of the book today, but I decided to take more time and read. Since OCaml is a functional language, there's a lot to cover about functions. Let's get started. Methods and functions are not the same idea. A method is a component of an object, and it implicitly has a receiver that is usually accessed with a keyword like this or self. OCaml functions are not methods. They are not components of objects, and they do not have a receiver. Some might say that all methods are functions, but not all functions are methods. Some might even quibble with that, making a distinction between functions and procedures. The latter would be functions that do not return any meaningful value, such as a void return type in Java or none return value in Python. So if you're coming from an object-oriented background, be careful about the terminology. Everything here is strictly a function, not a method. Okay, function definitions. We've already talked about this a little bit. I don't need that much help with function definitions, so I might go through this pretty quick. I think the main thing to know is that it's let name arguments equals body. Yep. And that if you have a recursive function, you have to use the rec keyword. Yep. One of the best known recursive functions is the factorial function. In OCaml, it can be written as follows. Let rec fact n equals if n equals 0, then 1, else n times fact n minus 1. Very exciting. Okay. And then is he finally going to get into multi-argument functions? Note that as in many languages, OCaml integers are not the mathematical integers, but are limited to a fixed number of bits. We already talked about this, that they're I63s. Why are you repeating this? Why are you repeating yourself? Inefficient factorial implementation, though. Classic inefficiency. Here's another recursive function. Let rect pow xy if y equals 0, then 1. Else x times pow x, y minus 1. Very exciting. Okay, didn't have to write any types. Starting to show what multiple argument functions look like, even though I don't think he's actually explained this yet. Syntax for function definitions. F, x1, x2, blah, blah, blah. Yeah, must begin with a lowercase letter. Important note. Your function names have to begin with a lowercase letter. Note that syntax for function definitions is actually simplified compared to what OCaml really allows. Sure. Mutually recursive functions can be defined with the AND keyword. Okay? Let rec, even, and odd. Okay. I forgot that was a thing in OCaml. Because it takes linear stack space. Oh, right. The syntax for function types is tu, t1, t2, u, t1, tn, u. Okay, right. So now he's finally explaining this. Basically, the point is, since OCaml functions are auto-curried, right? Like, the point is that your first argument technically returns a function that takes all of your other arguments, right? And then it keeps going and going and going, right? Well, this is just a function that takes one argument, right? Takes a t and returns a u. This takes a t1, which returns a function that takes a t2 that returns a u. So you could read it that way. Anonymous functions. Yep. And we can also write it as fun. So we can do like let in, let function arguments, or we can use the fun syntax. They mean the same thing. Anonymous functions are also called lambda expressions, a term that comes from the lambda calculus. How about it? Which is a mathematical model of computation in the same sense that Turing machines are a model of computation. In the lambda calculus, fun x to e would be written lambda x dot e. The lambda denotes an anonymous function. It might seem a little mysterious right now why we would want functions that have no names. Don't worry. What? Like, really? Do people coming from other programming languages not like I mean most languages at this point have anonymous functions. This is just like, this is where I'm like, is this book actually written for beginners? But maybe this is just because it's also written for college students. So not exactly beginners. We don't mean we don't mean the profit type of college students here. We mean, sorry, university students, right? In the US, I'm sure most people know. We tend to use college and university somewhat interchangeably. Static semantics. Very exciting. Okay. So yeah, I don't know. I just thought that was kind of weird. I don't think most programmers would think it's mysterious why we would want an anonymous function. I don't think I ever thought that. Okay, function application. Here we cover a simplified syntax of function application compared to what OCaml actually allows. Let's see if I actually care about this. Nope. Okay. Anywhere let x equals e1 and e2 appears in a program, we could replace it with fun x to e2, e1. They are syntactically different but semantically equivalent. In essence, let expressions are just syntactic sugar for anonymous function application. Yes, sure. Fine. When you think about this, I don't know if I really... Do I care about this? Do I care about this? I already said I didn't, and then this sentence threw me off. I wonder if this note is like somebody saying, actually, okay. Lets are generalized, so you can do let f equals fun x to x in f5 fa, but not fun f. Yeah, f5 fa fun x x. Yeah. Simplification, maybe. Maybe it's just a simplification. But it still is an absolute statement of a simplification. Okay. There's a built-in fix operator in OCaml. This is called Prophet's favorite OCaml operator, called the pipeline operator. Written pipe, right arrow. So basically it's just pipe. So instead of writing square ink 5, we can write 5 ink square. 5 pipe to ink pipe to square. Yep, we can do that. This is so annoying. I mean, not like this actually makes sense in most code, but it looks so bad. But yeah, basically, instead of having to read right to left, you could read left to right. Special. So yeah, I think a lot of people at this point are pretty used to pipes. Or it just makes kind of like sense inherently. Okay, exciting. Pipeline operator, already knew about it. Identity function is the function that simply returns its input. Okay, why are we talking about the identity function? Oh, polymorphic functions. Okay, might help if I read the title. The prime A is a type variable. It stands for an unknown type, just like a regular variable stands for an unknown value. It'd be like T, and a capital T in Java, right? Or Rust. Type variables always begin with a single quote. Commonly used type variables include prime A, prime B, prime C, which OCaml programmers typically pronounce in Greek, alpha, beta, and gamma. It's not how you pronounce it in Greek. Sorry, it's just not. Just kidding. Why don't you just say A, B, and C? Come on. We can apply the identity function to any type of value we like. ID 42, ID true, ID big red. Because you can apply ID to many types of values, it is a polymorphic function. So this is basically just saying this is how generics work. That's true. Imagine not being able to use special characters. Unbelievable. Okay. Because you can apply ID to many types of values. We already read that. So yeah, parametric polymorphism, generics, you know, that whole thing. It's pretty exciting. Yep. Yep. If you don't know what generics are or parametric polymorphism, you can read the section. But yeah, basically the little prime thing, the little single quote, important. Important for specifying a generic type. You'll need that. Good. It warms me up every time. For some reason, whenever I have the fire on and I'm streaming, it just warms me up. I'm sure it has nothing to do with my MacBook, my Intel MacBook. That literally, let's see, it's like half a second. I can touch it without burning myself, but if I held my finger on it, it would probably burn. It's pretty exciting. I get a computer and a space heater all in one. Yeah, not related. No, it's the fire. The fire is what warms everything. All right, we have 15 minutes. We can probably get through functions. Yeah, it's so efficient. That's what I'm telling you. I try to explain it to people and they just don't get it. Okay. OCaml therefore instantiates the type variable alpha to int, thus preventing us from applying id prime to non-integers. Okay? Yep, we know this. More mechanical way to think about all this in terms of application. By that, we mean the very same notion of how a function is applied to arguments. When evaluating the application ID 5, the argument x is instantiated with value 5. Likewise, the alpha in the type of ID is being instantiated with type int at that application. So if we write id int equals id, we are in fact instantiating the alpha in the type of ID with the type int. Yep. Okay. I don't feel like you have to explain this anymore, but that's okay. We can do that applying function to arguments that reveal what the type instantiation should be as an ID 5 or by a type annotation as an ID int, among other ways, but we have to be consistent with the instantiation. For example, we cannot take a function of type alpha to beta to alpha instantiated at type int to beta to a string because the instantiation of alpha is not the same type in each of the two places it occurred. Yeah. Makes sense? Just like normal algebra, that a has to mean the same thing in the whole equation. You can't change what a means later on. Labeled and optional arguments. Yep, very cool. OCaml is labeled and optional arguments. Here's the syntax. I've already used this, so I kind of know how it works. But basically, you can specify the name with tilde and instead of saying arg1, you can call it like this: name2 3, name1 4. But most of the time you'll just see it this way, because why would you give it a name that you're not going to then use in your function? That would be kind of weird. They're not even explaining how let f alpha to alpha doesn't necessarily declare a function of type alpha to alpha. Okay, you'll have to explain it then, Prophet. What else would that declare besides a function? Oh, like, oh, funny. Yeah, because you have a Haskell job, right? Really, you have a job, what, writing Go or writing front end code? I know, but they use Haskell at your work. So yeah, most of the time, so you can give the argument name and the what would we call it? The argument and the parameter different names. Arguments are often the same name as the variable names for them. Yeah, sure. Okay. Argument versus variable. I don't write Haskell. The other team does, and they refuse to write docs. Yeah. Classic Haskell programmers. The code is self-document. Why would you need docs when you can just look at the type? Just look at the type. Use of labeled arguments is largely a matter of taste. They convey extra information, but they can also add clutter to types. Yep. Yeah, I mean, I think it's really cool to have named arguments, but I feel like it's something that people probably already overuse. But I don't know. We'll see if I feel that way when I write more OCaml. I don't always like named arguments. You can then call a function with or without the argument. Mm-hmm. Right. And this is just explaining the wait, what? Did he not give he didn't give the more obvious? Why didn't he give the other example for a default? It is nice to be able to switch up the order. Yeah, I think that is cool. I think what I'm trying to say, I think for library code, named arguments is lovely. I think for business logic code, I would start to get annoyed if every single function I used name arguments. But that's just like my visceral take coming from languages that don't have named arguments. I mean, you can still write them, you can still call it positionally, right? Like, as in, if I said let inc n equals n plus 1, and then I say inc1, label n was omitted in the application, so they want you, see, this is what I hate. This is what I start to hate. Do I have to do it this way? I always forget. Yeah. Okay. What is confusing to me is, let's do an inc prime. And let's do a named argument with a default. And then we have to take a unit equals n plus 1. Why would you want to do this? I don't know. A better optional argument would be like what you increment by, but no, we're just going to do this for fun because everything I do is a mean. So let's see. Does that really not work? Am I crazy? Is this not the syntax for this? This expression has type int. This is not a function. It cannot be applied. Oh no, it's not. It's not this, is it? Am I forgetting how this works? Unbound value in. Okay. How did he do it? Oh, I forgot the optional. That was the problem. I forgot to mark this as optional. It's this, isn't it? No? Let's keep reading. No, he doesn't explain it. He just gives this thing. And there's a shorthand for this. You need parens? I thought there was a shorthand for that. Maybe there's not. Is there no shorthand and I'm just misremembering? That is how you have to do it? Or can I just do this? That's what it is. Okay. Okay, we've learned we learned something that we already knew. You need parens. The shorthand, yeah, okay. I got there. That makes sense. It is really dumb to me that he doesn't provide what the shorthand is here. Because most of the time you're not going to want to do this. You're going to want to just do name equals 8. It's really terrible. I hope this person knows that I'm not like, wow, your book sucks. This is a great book. It's amazing that you put this for free on the internet. It's helped so many people. Blah, blah, blah. Right? Okay, disclaimer time. But we're just being honest here. It's a little confusing. Like, just give me the name equals 8 syntax, because that's how I'm going to use it 99% of the time. Okay. We could define an addition function as follows. Let add xy equals x plus y. Yep. Okay. Wait, I missed something. Function add x takes an integer x and returns a function of type int to int that will add x to whatever is passed to it. Oh, sure. The type of add x is int to int to int. The type of add is also int to int to int. So from the perspective of their types, they are the same function, but the form of add x suggests something interesting. We can apply it to just a single argument. Why can't you do that with... Oh, he's just explaining currying. Maybe if I didn't know how currying works already, I would find this to be like, oh yeah, cool. And then be like, whoa, mind blown. But like, to me, this is just confusing AF. That was confusing. Okay, it's fine. This works because the following 3 functions are syntactically, it's his favorite line. Classic college professor. Say the same thing over and over again. I almost was going to be a college professor one day. A long time ago, one day, I thought I would go into teaching. Not in CS. So add is really a function that takes an argument x and returns a function f fun y x plus y, which leads us to a deep truth. The deep truth. Function associativity. Yep. Okay. So this is just explaining currying, which is helpful for people that don't understand it. We kind of already talked about it. Operators as functions. Yeah. So you can use operators as functions by wrapping them in parens, or make them prefix operators, however you want to say that. Works for any built-in operator, and also learns you how to create your own operators. Very exciting. Yeah. The main thing you have to be careful of is precedence, which is not explicit always in the OCaml. Okay, finally tail recursion, and then we're going to end for today. we got through functions. It was a big section, okay? Consider the following seemingly uninteresting function which counts from 1 to n. Counting to 10 is no problem. Counting to 100,000 is no problem. But try counting to 1 million. All right, so tail recursion, TCO, all good to know about. Basically, what happens here is that it's similar to what Prophet was saying with the factorial function earlier, is that we're continually just adding things to the stack as we go along. We're not like actually getting that result and then going on to the next thing. But TCO fixes such things. So basically, suppose that a recursive function f calls itself and returns the result of that recursive call. Our count function does not do that. Let rec count n equals blah, 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 right? So 1 plus count n minus 1. So what's actually happening there? Okay, he explains it. Rather, after the recursive call, count n minus 1, there's computation remaining. The computer still needs to add 1 to the result of that call, but we as programmers could rewrite the count function so that it does not need to do any additional computation after the recursive call. The trick is to create a helper function with an extra parameter. Yay. Function count aux is almost the same as our original count, but it adds an extra parameter named acc, which is idiomatic and stands for accumulator. The idea is that the value we want to return from the function is slowly, with each recursive call being accumulated in it. The remaining computation, the addition of 1, now happens before the recursive call, not after. When the base case of the recursion finally arrives, the function now returns acc where the answer has been accumulated. Yep. I would like it if there was, yeah, so basically the point is tail position matters, right? Okay, he did put it right here. That's nice. Good job. Good job. He put it right next to each other. So, right, because here our tail call is 1 plus recursive call, and here our tail call is just recursive call. There's no additional computation. We can just keep going. We aren't having, the compiler knows that it doesn't have to keep the stack the whole way, right? It can recycle the space used by the previous frame. It knows it doesn't need that result anymore, basically. So there you go, TCO. Great that OCaml has TCO. Obviously. And okay, so he actually, oh, that's funny. He actually goes through and talks about how his factorial isn't great. He's like, let's change this to become tail recursive. Okay, cool. Great. Awesome. So yeah, tail recursion, all that. This is pinned if anybody wants to follow through the book. I'll probably do another stream of this. To get through the rest of it. I probably am. It might take 2 streams, I guess. I guess this might actually take 3 streams to actually get through all of it. So we'll see. We'll see how long it takes. It doesn't really matter. It's been fun just to like refresh things that I already knew, read it kind of from front to back, and just also make fun of somebody's hard work that they put into a book, right? Always fun. So just kidding. So I'll be back with this another time. We might do more Sunday if we're not doing Nixon night. I have to decide if I'm going to stream on Sunday. Not sure yet. But either way, I'll be back on Monday. We'll probably be continuing some Nix stuff on Monday, trying to get Riot's Nix builds back to working again, fix some issues that I discovered earlier this week. So we should be doing that. Wednesdays are Rust and Fridays are OCaml. So until next time, I'll see you.